All right, let's go over this warm-up. Says for the following polynomial graph, determine any x values where the graph has a local extremum. It's like an extrema, extremes. If the graph does not have one, we put NA. Okay, so what's another word for relative max and mins? No. That would be local. Local and relative, that can be used interchangeably. And that means it's right, all of them. Anything that's a maximum that in its little neighborhood, and it can occur at the endpoints. So we have 1, 2, 3 relative or local maximums. They are at x equals -2, 2, and 8. We agree with that? All right, so then relative or local minimums, I have 1, 2, 3 of those. And those occur at -1, 4, and 9. Okay, are we all okay with those? This. All right, now absolute maximums. Do I have an absolute maximum? Yeah. Yes, looks like right there, right? Now, if this end went like that, then what do I have an absolute maximum? No, because that would go to infinity, even if the arrow is like lower than that. So be careful not to miss that. That's not what's happening, no. So I do have one at x equals 8. And then do I have an absolute minimum? Yes, it is right here at x equals -1. Now, notice that it says absolute maximums and minimums. That is actually plural. If you think about one of the sinusoidal functions that we've been talking about, it looks like that, but a whole lot better. Then I would actually have an infinite amount of absolute maximums, and that's totally possible. Obviously, they all have to be at the same y value, but that's one reason, because you can have more than one, but they would have to have the same output value. Okay, this next one. How many points of inflection does the graph have? All right, so look, I am concave up here, up here, up here, right? It is concave down here, and here, and here. Your point of inflection occurs when you change concavity. So I change here, 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 and here. That is 5 changes. So there are 5 points of inflection here. Any questions about that? Okay. As long as you got the same answer and you know what happens. But I get a lot of people want to give me 6 here for some reason. Nobody can explain to me why, but it's a very common wrong answer for that one. So I think if you actually mark what's happening, and then you can just see where it changes. Just an easy way to not mess that up. Okie dokie. Here I want to find the degree, so I'm going to do that hopefully by my differences. Do I have equal length input value intervals? Yes, I have equal length input value intervals, so I can totally do that. Now, when you do that, you have to be able to subtract correctly. So -5 minus a -7 is 2. -7 minus a -5 is a -2. -8 minus a -7, -1. -5 minus a -8, +3. 3 minus a -5, 8. Okay? If you can't subtract correctly, then it's not going to do you any good. Now, clearly not linear because they're not all the same. So I go on to my second differences. -2 minus 2, -4. -1 minus a -2, 1. 3 minus a -1, 4. 8 minus 3, 5. Also not quadratic, right? So I go again. 1 minus a -4, 5. 4 minus 1, 3. 5 minus 4, 1. Also not cubic, I hope, or maybe one of my numbers is wrong. It's the other thing that could happen to you. 3 minus 5, -2. 1 minus 3, -2. If those hadn't matched, I'm out of stuff to compare. So either I can't tell from this chart, or I know that it's greater than 4 or something like that, or more possibly I have a number wrong somewhere. But these are the same, so that would be 1, 2, 3, 4. That is a degree of 4. Okay. What questions do we have? Anything? All right, put those away until next time. Let's go on page 87. Whoops, I'm in the wrong one here. There we go. Let's go on page 87. Okay. All right, deep breaths. Everybody take a deep breath and close your mouth. All right. So last week, we learned how to identify the midline, amplitude, and period from a graph of a sinusoidal function. So now we're going to look to see how that affects the equations. All right. We are doing transformations. They are the same transformations you've been doing forever. So don't overthink anything and make it harder for absolutely no reason. So let's draw a little, I'm going to draw a little bitty, we'll just do like a little sine curve there. And so we understand what the midline is. The midline for a parent function is the x-axis, but it shifts with the graph, so it really doesn't matter where the axis is. That would be my midline, okay? And all the midline is a vertical translation. Okay? That's what it represents. That's how you can figure out what's what. Okay? Vertical translation, shifted up and down, just goes along with it. Then we have the amplitude of my very much not drawn to scale drawing, because those little pieces there should be even and they're not, but that's okay. Amplitude goes from the midline to a maximum or midline to a minimum. And so your amplitude for the parent function is 1. That's the largest sine and cosine value you have. But then I can stretch or shrink that. So that means that this is a vertical dilation. Then the period. Remember, the period is how many units does it take to create one cycle of whatever is happening. Okay, and so we can take that cycle could be really short, or it could be really long, just either way. So that is a horizontal dilation. Okay, does that make sense? Okay, all those little things that we talked about, how it works in with your transformations. Okay, so we're going to start by, and we'll get to horizontal translation. We're going to talk about that one a little bit separately. So right now we're just looking at these three. So they have given us these functions, f of theta and k of theta. One is sine, one is cosine. Your a is out front there. That's your vertical dilation, just like it's always been. B, that's your horizontal dilation, like it's always been. And then that plus or minus d at the end, that is just your vertical translation. Exact same stuff, okay? So if I have a vertical dilation, it's always by a factor of the absolute value of a. Because the negative a, what happens if a is negative? I get a reflection across what? X-axis, good. It's a reflection across the x-axis. So the negative means something else, right? That's why the vertical dilation factor, that's the absolute value of a, and the absolute value of a represents the amplitude of the graph. Okay. Vertical translation, that is d units. We used h and k last semester because that's just how they did it for other things. And since that represents the midline, anytime you're going to write it as a line, it's got to be y equals, because it's an equation of a line. Then horizontal dilation. Remember, x is a liar. Theta is our trig version of x. He's just as bad as x is, so he's also a liar. So even though we see a b in here, the dilation factor is actually absolute value of 1 over b. And again, it's the absolute value because if it was negative, we'd have a reflection. This is tied to the period. It does not represent the period. Okay, so the period is given by 2 pi. That's the period of the parent function for sine or cosine, and you divide that by b. Or if you need b and you have the period, it's 2 pi divided by the period. So you just take 2 pi divided by one of them, you get the other one. Okay, but it's not something that we can just pull out of the equation and then it just works. And 2 pi, that's the period for your parent functions for sine and cosine only. We good so far? Any questions? All right. All that should look pretty familiar to you, I hope. All right, so now let's look at this. We're going to start off with a very simple one where they kind of tell us everything. The graph of the sinusoidal function h is shown in the figure above, along with the information. Just like I said, it gives you everything. And then anytime you need certain information, it'll give you a little what I call like a naked function where it doesn't have any letters in it, just telling you basically that I know that this is a sine function and I'm going to have transformations in it. And I'm supposed to find A, B, and D. A is the amplitude. It is this right here. I don't even have to count because it flat out gave it to me. That's 6. Okay. Easy. The midline, it's right here. It's drawn in, and they gave it to me. Midline y equals 3, so that's this value. Then I should be able to figure it out, but it tells me what the period is. That is not the b value. To find b, you take 2 pi, you divide it by the period. That gives you the b value. Any questions at all? We're good? Easy enough? It's really not that bad. All right, flip it over. Now it's asking me for to write the expression. In order for me to write an expression, I got to have A, B, and D. We'll get to C in just a little bit. This is my parent function for sine. This is my parent function for cosine. We have not talked about vertical translations yet, which means I can't shift this left or right. So do you think I'm going to be writing an equation for sine or cosine? Sine. Sine starts at 0, 0, but really that's the parent function. It's starting on the midline. So here's the midline, right? You think about it got shifted up. So I'm starting right there. That means that this is definitely a sine function. Okay. So midline, I just figured it out. It's there at y equals 3. So that's that value. What is my amplitude? 3. It's also 3, right? It's coincidence that they're the same. Then to find b, I need the period. What is the period here? Pi. Start here, end here. It is pi. Period is pi. So b is 2 pi divided by the period, which gives me 2. Okay. So since I decided I'm writing a sine function, this is going to be f of theta equals a times the sine of b times theta plus d. Okay. And then I have a, b, and d. I can just plug those in. I get f of theta equals 3 times the sine of 2 theta plus 3. Okay. Any questions at all? Okay. Yes, the pi's cancel out right there, yes. All right, are we all good? Any questions at all? All right. Oh, my goodness gracious. Okay. So let's look at this one. I'm going to give you a minute to talk about it and think about it and see if you can come up with the answer here. Okay, let's talk about this. It's asking about the period and amplitude. Nobody asked for the midline, but I like to draw that midline in. I think it kind of helps everything make a little bit more sense. My midline is at y equals -1. Again, nobody asked me, but that's okay. Given that, what is my amplitude? 2. I can count it here or here, but the amplitude is 2, so I can eliminate these two real easily. Okay. Then I'm looking for the period. Now, the period, you can start and end anywhere, but if I start at 0, a lot of times that makes things a little bit easier. That's one cycle, so I'm going from 0 to pi. My answer is A. This was about the time that somebody earlier today said, are all the periods always pi? The answer to that is no. And I think that these are all coming up kind of pi just because it's the easiest thing to do when we're first learning it. But I probably should go back and change some of these because I don't want you to be under the impression that it's always pi. Okay, that's how you get a false sense of what's going on. Now, nobody asked me. I didn't have to match it up to an equation, and nobody asked me to write one. But without a translation left and right, we know that this would be sine theta, right? And then this would be negative sine theta because I would just reflect it in the x-axis. So I could make that a negative sine graph without having to move left or right. Okay, just throwing that out there as an option. Okay, we're okay. I mean, again, it didn't ask me that. It's just something we need to look at. Okay, we're good? All right, let's look at this one. Now, we did one very similar to this last week. So as a trigonometric function k has a maximum at this point. After this maximum, the next minimum occurs at this point. Now, these answers all say cosine, but even if they said sine, I could still draw the same thing just to get myself started here. But I have a maximum and then a minimum, so it's really going to look like this. This point is at 0, 6. This point is at pi halves -4. Okay. Now, I can see over here that with my answer choices, pretty sure my midline's at 1 because they all have a 1 right there. And so whatever, it's in there somewhere. That doesn't even really look like it's in the middle. But I also need my amplitude and I need the period. I need to figure those out. If I want the amplitude, what is the amplitude? What do you think? 5? So you can look at it this way. There's 6 units above and there's 4 units below, so that's a total of 10. But that's going the whole way, so the amplitude is just half of that, and it is 5. So that means I can eliminate A and B. Then, to find the period, I'm looking at my input values, going from 0 to pi halves. This length right here is pi halves. How much of the period is that? Half of the period. So that means the period is actually pi, again. So then B is 2 pi divided by pi, which makes it 2. What questions do we have? Anything? All right, grab your other sheet of paper. All right. This is also going on page 87. I'm going to give you a minute. I want you to look at this one. Think about it. Talk about it. Okay, so the first thing I like to look at, because I think it's the easiest one to kind of eliminate something, is the midline. It's a -1. I drew it in for all of them. Clearly, that's not the midline of that one. So A is out. Okay. Then I can look at the amplitude. Well, the amplitude is 3 in all of these, so that really didn't help me any. And then I have this 2x, so I know that B equals 2, which means the period is 2 pi divided by 2, which gives me pi again. And if I look here, that gets me to 2 pi, not my answer. Oops, not my answer. Not trying to circle it. This gets me to pi halves, not my answer. Hopefully this one gets me to pi. Yep, that one gets to pi. My answer is C. Okay. What questions we got? We good? All right. Now let's talk about this horizontal translation. Has a fancy name for trig. It's called a phase shift. So a horizontal translation of a sinusoidal function is called a phase shift. Phase. A phase shift. All right, listen. We've got g of x equals sine of x plus c. There's literally the only transformation right there. It's a phase shift by -c units. Now I want you to look at this, and you're going to have to look at it on your own paper in just a second because I'm about to click on something else. I want you to look at that versus this. Okay, this is what we did last semester. This has all the transformations in it, right? But like I said, last semester we used H and K because that's what they did with these. But remember, the letters could be anything. It's where they are, right? So this is like what we're looking at right now for trig. Besides the fact that that's an H and you have a C, what else is different? It's a plus instead of a minus. And that is a terrible, terrible thing that they have done. You can ask any high school math teacher and anybody that teaches AP Pre-Cal. None of us are happy with this. People will try and just say, oh, yeah, but they should know. Okay, yeah, but it's just a mean thing to throw in there for nobody has a good reason as to why. I think the only person that likes it that way is whoever wrote that stuff for College Board. So here's the deal. X is still a liar. Theta, what, T, whatever we have in there. If all we're doing is writing an equation or understanding an equation, nothing changes about how you have it. Okay, if it's x minus whatever, we go to the right. If it's plus, we go to the left, just like you've been doing. The problem comes in when they ask you, like they do on the trig stuff a lot, not to write the equation, but what is A, B, and C? And if you don't pull it out of the equation correctly, your sign is backwards, your SIGN. Okay, so it's a very simple thing to miss if you're not paying attention. Okay, so I'm going to stress this a lot. I'm going to tell you what I do to make sure I get my mind wrapped around it, because you can also overthink it and then still get it backwards. We're all good at that, right? We're really good at overthinking things. So pay attention to that. The good news is this, that they always give you like a little generic one when it's necessary. But let's look at this. We're going to talk about that plus C stuff here just a little bit. Okay, this says, the figure shows the graph of a trigonometric function g, which of the following could be an expression, because there are literally an infinite amount of equations I could actually write. I've got 2 cosines and 2 sines, so I want you to remember that you got sine, it looks like this, that's sine theta, and then you got cosine, it looks like this, cosine theta, just to wrap your little mind around it, okay? Now, we can translate left and right, so it may not be so obvious looking at it, because I could write, if I could just write my own equation, I could write you an infinite amount of sines and an infinite amount of cosines for this graph, but we're having to match this stuff up. Okay, so here, well, actually first, they all have a -1 for my midline, so that's all great. Then A, the amplitude is 3 for all of them, but some of them are negative, so there's a reflection there. And then we've got the C going on in here where we're shifting left and right. If I look at this one, I'm not shifting anywhere, right? This one, I'm going, because it's x minus pi, just like we've always seen before, we're going to the right. This is x plus, which means we're going to the left. This is x minus, which means we're going to the right. Do you see how that concept, that does not change? Here's what you have to be careful with. If they tell me it is x plus c, then when I take that out, if this says x plus c, that means c right here is a negative pi, even though I'm going to the right. Isn't that stupid? But that's the way it is, okay? This, because x plus c, this is literally c right here. C is pi halves. And this will be c is equal to negative 3 pi halves. Because instead of saying we are translating c units, look at what they have. It's a translation by negative c units, which is, it's not wrong. It's just, why can't it be the same, right? So we can debate it and we can complain all day long, but at the end of the day, this is what they're asking you for. X is a liar. So since I c minus, I'm going to the right. But because we have this written as x plus c, if I'm asking you just for the c value, you have to make sure you're taking it out of there correctly. I know, I agree, it's mean. It's not just dumb, it's mean. Because they're throwing this in there on, like if they did it all year long with everything, that's different, but throwing it in there with something that's new to y'all. This is it. This is on FRQ3. I mean, they ask you for this, and we're gonna make sure you write it down and that we wrap our minds around it, okay? It's all gonna be okay, but you gotta pay attention to what I'm saying. You gotta practice yourself, okay? So, but for this question now, let's go and actually try and figure this one out. This one I'm not moving anywhere, right? So cosine starts at a maximum above the midline. Like this is my parent function, so that is the x and y axis, but at the parent function, the x-axis is the midline. So I have to start up there. This one, and I'm not shifting left or right. This starts down, not up, and since I'm not shifting, it can't be A. We're okay with that? This one, cosine I know normally starts up here, but you see that negative? That means it's actually going to start below the midline, like this one does. That's okay so far, but I'm supposed to translate to the right pi. So if I start here and go to the right pi, I'm not on my graph. So it can't be B. Everybody with me on what I'm doing so far? Sine starts on the midline. So sine would start right here, okay? And then I'm supposed to go to the left pi halves. Well, I wrote over here, but I can make it go back like that. Okay, so that would, if pi halves, I'd be on my graph. That's great. But if A is positive, does sine start by going down? No, it starts by going up. So I don't think it's C either. So we really hope we like D. And then we have the, I'm here. I start here again. I move to the right 3 pi halves. I end up here. I'm on my graph. That's good. But because that's negative, it's supposed to go below first, then above, and it does. So everything looks good here. The answer is D. Okay? Questions? Well, you're going to be skipping a lot on the test then, dear. Like I've said before, and I'm going to keep saying, this stuff is brand new to you. You are not going to get it if you don't practice. You have to practice these, okay? They're really not that bad once you get your mind wrapped around it. All right, any questions at this point? All right, flip it over. It's not. I'm going to give you a second to look at this, or a minute or so. Actually, for time purposes, let's just work it together because I don't want to be screaming over announcements. All right, the figure shows the graph of function h. Which of the following, again, could be an expression? All right, so all of them have the midline at 1. They all have an a value of 2. But again, we have sine and cosine mixed. We also have a b value of 2, which, guess what? The period is pi. And so we got sine and cosine. All right, so let's start with this. And every single one of these means we're going to the right. Nobody's asking me for C, so I don't have to get all worried about getting stuff backwards. It's still X is a liar like we've been thinking about. So if it's cosine, cosine starts above here. So cosine would start here, and then I move to the right pi force. That would put me right there. Is that on my graph? No, my answer is not A. Cosine, again, starts up here. I move to the right pi. Nope, I'm not on my graph. If this had been a reflection, then I'd be okay, but it's not. So then sine starts on the midline. Sine would start right here. And then I'm going to move to the right pi fourths. Right pi fourths. That looks pretty good. And then there's no reflection, so it should go up and then down. I really think C looks good, but we got to check the last one here. And so I start here again. If I move to the right pi, not on my graph, so I don't like D. My answer is C. Okay. Questions? You got to kind of talk your way through it there. Anything at all? All right. Now, this last one looks like what's on FRQ3, but all the wordy stuff is not here. They have literally given us the ordered pairs and where they go. So go ahead and just label them on there. Well, it is because you're saying it is and you're making it hard. So on this, on the actual exam, you will be told what kind of form of an equation you need. It could be sine or it could be cosine. And then they're just asking me for A, B, C, and D. Okay. All right. So once again, I think midline, it's already even drawn in there for you. Midline is at y equals what? 11. So that makes that 11. Then what is my amplitude? 5? Or is it 3? 3? What? Amplitude, is amplitude a vertical length or a horizontal length? Vertical. So which values am I looking at? Y. So that does make it 5. No, but I had it. Huh? Well, I had a lot of 3 answers, so I'm just asking you. All right. Do we understand why it's 5? Okay. Then B has to do with the period, right? So here's the period. I can start here and end here, even though it says it's sine, it doesn't matter. That's the easiest place to start and end. So the period, what do I look at? The inputs or the outputs? The inputs. So what is the period? 12. Go from 2 to 14, it's 12. So I take 2 pi divided by 12. That gives me pi 6. Now remember on these, there's an x and a y axis somewhere. We don't know where. It's not there, but it still works like an x and y axis. And I need to figure out my shift here to get C. Well, if I keep going like so, okay, I don't even have to do that much, but I can get this point. What is that ordered pair going to be? -1, 11. Okay. This is sine. I know that because they told me it's sine. Sine is supposed to start on the midline like this. This is my start, one of my possible starting points, which means that if I normally start at 0, but I started at -1, I went to the left 1. You with me on that? So I'm not just writing C down. I'm going to say I went to the left 1, which means that I'm going to write T plus 1. We agree with that? That means I go to the left, because the way we understand how it goes in, that does not change. Next to it, I'm going to write what they have, which is T plus C. Because of the stupid way they did it, but we're not going to say that, well, I guess I probably would say that to their face, but it's okay. What is C? 1. C is 1. That's why I'm telling you, write that down, as silly as that seems. Okay, but here's the other thing. I didn't have to go to the left. I could have gone to the right, and I could have started there. Is that okay? So that means I could have had T, well, y'all are putting up, I ain't even done. T minus 11. That means I go to the right 11, yes? Since this is T plus C, what would C equal? Negative 11. And it could be either one of them, totally fine. I could actually make A negative value and do some reflections, but we don't need to get fancy. We ain't trying to get fancy up in here on this, okay? We good? Questions? All right, now you can put that away.